Greetings, and thank you for joining us for another SANS ICS concept overview. I'm Don C. Weber of Cutaway Security and a certified SANS instructor. In this video, we will discuss using a simple process published by the United States National Security Agency's Information Assurance Directorate. The process we will discuss is the Position 0 Integrity Checking Windows-Based ICS and SCADA Systems. This manual process is a simple way to gather information about a Windows systems within your control network that will generate a baseline of current configurations. Understanding and using these techniques will improve recovery times for your process in the event of unusual activity or a compromise. If you enjoy this video and the topics we cover in the SANS ICS concept overviews, be sure to like and subscribe to the channel. Leave a comment if you have a question about this topic or suggestions for future content. I was doing some research for one of the next ICS concept videos, and one of the search results was really interesting to me, so I thought I'd check it out, and I was pleasantly surprised, so I wanted to talk about it today. And the link that popped up was associated with the United States National Security Agency, so the NSA. And when I went into review the site, I saw that they have an Information Assurance Directorate. And it appears that this part of their organization is tasked with providing guidance to, government organizations and to the public associated with certain security configurations that might be useful within their environments. And as we can see here on the website, we can see that they have an industrial control systems area. And so when I started scrolling through there, I thought that was interesting. They have guidance on assessing the mess, so I assume gathering information about your assets and doing some asset management. They talk about application whitelisting, which might be a good topic for us to discuss in the future. But what really popped out at me was this Position 0, Integrity Checking Windows-Based ICS and SCADA Systems. And it was the incident responder background in me that kind of honed in on this, because doing integrity checking is a valuable tool to understanding what is going on within your environment to help prioritize some of your efforts. If you can take a snapshot of a system or configuration file right now, and then if something's going on, you can take another snapshot, perhaps 6 months later, current, and if you compare the two outcomes of that snapshot, any differences are things that you need to investigate. It's really helping you hone in on and weed out anything that is common within your environment. So integrity checking involves creating a baseline of information that we can compare things to, and anything's different, we want to investigate. And potentially it's going to be pointing out, when we're talking about compromises, it's going to be pointing out things that the attackers have done to our network, to our process, and we can use that to decide what actions we're going to take. So with that, of course, as soon as I saw that, I wanted to review the document, and I went out there and started reading it, and I was pleasantly surprised. Instantly I knew that they're going to, when I saw that they're going to talk about the Windows command prompt, I knew what they're doing. And what they're doing is they're providing information to the people that are using this and telling them how to leverage the tools that are provided by the Windows operating system to gather this baseline information for integrity checking. And why that's important is because there are third-party tools out there that do this. You can purchase a commercial solution or even download some open source ones, but you have to install it on the system. And that can be a problem within our control networks because the vendors and integrators, they don't like us making modifications to the systems. Even our process engineers don't want new programs on their systems because that can change the behavior, CPU and memory usage, increase the amount of network activity on the network just by implementing that software. But so instead of not buying those solutions and just not doing any type of baselining for integrity checking, what this guide outlines are the tools that are provided by the operating system that can be used to collect that information and we can create those baselines and compare things when it's necessary. And so this document just goes through the Windows command, talks about the Windows command prompt, how to start it. Most of us understand that. Some people might not understand that the different commands you can run within the terminal, within the Windows command prompt, you can get different output. And they use the example of the who am I. If you just run that normally, you'll just get information about your username. But if you give it the /all switch, you'll get a lot more detailed information about that user's account. And so we're going to take advantage of that when we're talking about gathering information from the system. Now, this information is in the NSA's document. SANS does provide similar information. If you go out to the SANS website, we have a blog, and one of last year's posts was the ultimate list of SANS cheat sheets. And by scrolling down in here, we can see that there's a large number of cheat sheets that have been developed by our instructors and by our students. And we've placed those online as a resource to everybody, a free resource to everybody. And, some students use this in the class, but a lot of people I've done this in the past as well. I keep these handy for my day-to-day jobs. If I need to do a quick reference of how do I do that again, these cheat sheets help. And as we can see, the very first one, Windows and Linux terminals and command lines. If we click on that, it'll take us to a cheat sheet that is leveraged by the SEC 301 and 401 classes, describing similar things to what we saw in the NSA document, which is just what is the command prompt, how do I interact with it, how do I use it, and to run commands and then output that information to text files. And we'll talk about that in a second. The one I started with, probably one of the first ones that I got, was generated by Ed Scotus, and we can see Windows command line cheat sheet, and we can see here he just provided a quick, and it's in the trifold fashion of the cheat sheets that they usually hand out in the classes. We can see he talks about task lists, how to interact with the registry over here. Okay, just some common things that you might be doing in the class, but also in your normal activities back at your job. So if we go look at the NSA's document and we scroll through all of their kind of, setup information, we get into the actual commands, obtaining system information. And one of the first commands they talk about is the system info command. And this is just an executable that's on every Windows operating system. You don't have to install anything. And if you run it, it will query the system and then print out all of that data to you. And let's go ahead and do that. I'm going to start down here at the run bar and call up CMD, which will call up the command prompt, and I'm going to run it as an administrator. And I want to run it as an administrator because some of the commands require system privileges. And if we run it as a normal user, we might not get any output at all, or we might get muted output, meaning that we don't have permissions to have access to all that information, and it will only display what we have permissions to do. So we want to run these commands as administrator because we want to collect as much information as possible. So once we have the command prompt open, let's type system info. And the executable, as I mentioned, will query the system, and then it will eventually output everything to the terminal. And we can see here, we've got the host name, starts with SANS and has a string identifying the system. We have data about the operating system at its current patch level. We have other information associated with the system, domain information. And we can see since the domain is workgroup, we know that this system is a standalone system. It's not attached to an Active Directory domain. We also see a list of all the hotfixes. I like to gather this information so that I can determine what patches haven't been applied to the system, and this will tell me whether or not the system is potentially vulnerable to some type of exploitation, remote code execution, or something like that. So I gather all of this information, and now I have it. I can store this information off. If I save this to a file, I can save it right now, and then in 3 months, if something's going on with the system, I can run this sysinfo command again, compare the two versions, and determine things like, has this system been updated? Has have patches been applied to it? You know, if it's not supposed to be updated, that could be in, and I do detect those types of changes, that could be something I need to investigate further. And so this is how we're going to gain an understanding of the current configuration, create a snapshot so we can compare it to later. Now the NSA document goes through and it talks about sysinfo, net start to get some of the services that are configured to start, task list, processes that are running right now. So if your system is set up to do its job within the control network, all of the task list should give you all of the active processes on there. If we have that snapshot and something is strange and going on in our environment, we run the task list again. If there are new processes, now we don't have to investigate every one of these processes. We can just investigate the ones that are new and determine whether or not that is something that is allowed or if it's something that could potentially be malicious. All of this information is extremely valuable when we're doing those types of investigative tasks. Okay. Now, all of this is interesting. We can run these commands in and output it, but we want to save this information so we can call it back up later. And so I want to give you a few kind of tips around how to save that information so you can use it later. In order to do that, though, I want to cover a few things that's provided by the operating system as well, so that we have something that's consistent across all of our systems, and we can output to a specific directory that has a timestamp and so forth. In order to do that, what I need to do is I need to talk about the environmental variables. So if I use the echo command, and I use the %, I can type one of the environmental variable names like computer name. And when I run this, it will output the computer name. And we saw that in the system info file. There are other things that can help us do what I'm about to do. And I want to identify a temporary directory. So for every user, the applications that are run by that user will store information that they produce, not on the desktop because that would fill everything up, not in the downloads directory or the documents directory. We need a location that those applications can store things so that they're out of the way of the user. And that's the temp directory. And as we can see here, by typing echo and using the environmental variable temp, we see that the student user's temp directory is an app data local temp. All right. So I'm going to use a combination of the computer name and the temp directory to create a storage folder. But if we're talking about time, looking back at snapshots, I want to also keep the time, right? And so I've generated this command right here. And what this command is going to do is it's going to use the time and date commands to generate a string that has the current time in it. So I'm just going to echo the date command, and I've given it some special formatting options. And when I hit enter, now I've got a string that has the year, date, month, and time that I ran these commands. Okay, and by combining all of those, if I want a directory, I'm going to make a directory, and then I'm going to tell it that, hey, make a directory in the user's temp directory. Let's start it with the computer name, and then give a dash, and then add this time date string on there. When I hit enter, I should have a new directory in the temp directory. So let's change into the temp directory, cd, change directory. Now I'm in the user's temp directory. And if I do a directory listing, dir, I should see a folder, a directory with the name of the system and the time date string. And I can change directories into that. Do a directory listing, and I should have an empty directory. And I do. Now what I can do is I can run the system info command and redirect the output that was printed out to the terminal. I can redirect that into a folder, or into a file. and I'm going to name that file with the name of the computer. So the computer name, I don't need a time date stamp because I have one on the directory, and sysinfo. So when I hit enter, the sysinfo executable should run, query all that information. And then when I do a directory listing, it has output all of that into the sysinfo file. And I can go take a look at that. I'm in the temp directory already. I can drill into our directory, open up the sysinfo, and that is all of the data that we had output by that command. Now I can save this, store this offline, and if there's an anomaly on the system, if I want to run this again, come back to the system, run the same command, and then compare the two files to detect what has changed for the system. And we can do that for each and every one of the commands that are provided in the NSA document. Okay. Now, the power of doing this is the fact that we're using the Windows operating system executables provided by the operating system. And we can do all of this manually by hand if we wanted to. So if we needed to send somebody out to every one of our systems and run all of these commands, we can give them a printout of the commands and they can type it in. But eventually somebody's going to make some type of error. They're going to mistype something. They're going to leave out an I in sysinfo, and it's going to be slightly different. And we want to provide our users with our administrators and the people going out collecting this information with the capabilities of not making mistakes. We want to reduce those mistakes to help speed up their efforts for information collection and evaluation. And we're going to do that by leveraging scripts. So first, I mean, if I was starting within the organization, we didn't have a lot of, and we needed education around collecting this information, I would start with this document and run all of these things by hand, okay? But eventually, I would hope that your organization gets to where they can actually generate scripts that will run all of these commands for you. It's already set up to do that. As an example for that, what I've done with the CutSec tools is I've created a system information scripts directory, so the sysinfo directory. And in here, I'm going to start a collection of scripts that will gather information from those systems just using the operating system tools. And in this case, because we're using the NSA's document, the position 0 document, I have generated a NSA P0 batch file, which is just a script that will run within the command prompt and run all of the commands that are provided within the NSA's document. So if we go review that script, it's calling it up, and we'll see that I start by building a directory within the user's temp directory. So I name the directory, and then I actually make during create it. So when I run this script, we should see a new directory with the current timestamp on there. Then I create a bunch of different file names for all of the commands that I'm going to run. The reason why we script this out is because if we typed all this by hand, I guarantee you I would make a mistake, and I would expect that at least one, somebody else running these by hand manually, they'll make one or two mistakes while they're typing all of this out. We want to avoid that. So we're going to script it up, create the file names, and then as you can see here, I've gone through all of the commands that were provided in the position 0 document, and I've included them in the scripts. So we can see that I'm running the sysinfo command, and then I'm redirecting to greater than signs is append the information, and we want to go ahead and append information to the file just in case, for instance, in the case of the system info file, it requires that because it's doing different things, and we don't want to overwrite the contents of the file. We actually want to add to the end of that file. Okay, and so it's just running the sysinfo file and then redirecting that into the file name that we've named previously that I showed you at the first part of the script. Now, all of these commands are useful for understanding what is going on in the system. So it's useful to creating that snapshot. it's not every command that is useful. There's more information that's provided by the operating system, other commands that you can run to gather a lot of valuable information. But I'm going to leave that to you and your teams to identify those things that are useful and then add that to your scripts. Okay, so this is just a starting script leveraging the NSA Position 0 document to guide that learning process for your team. But at the very least, if you needed to just to have something, this is a good starting point. So let's go ahead and run that. Let's go back. If I go back over to my folders, I can see that I've downloaded the script anyway already in our downloads directory. So I'm going to start a new command prompt as administrator so that I have the privileges to run all of those commands. When it comes up, I'm going to change into the directory with that file. And then when I do a directory listing, we should see the script there, and we can see it as the NSA P0.bat. So I'm just going to go ahead and type that script name, and when I hit enter, we should see it go through. This command prompt is going to read in this batch script and then go line by line, and if it has an executable line in there, it's going to run that line. And as we can see, it sets everything up, sets all our file names correctly, runs our sysinfo command and all of the other commands that were a part of the NSA Position 0 document. And as soon as this is done running, we should be able to go and check the temp directory again and see a new folder with all of this information in it. Should just take another second. We'll let it finish. Now we're going to change into, I'm going to change into the temp directory while it's completing its run, and I can tell it's finished. Now we have a new directory, and as we can see, it's I included the NSA script name in there, so we know which script we use to collect this information. And this has all of the files, all of the outputs from every one of the commands that we ran. So if we wanted to see the service lists, okay, we can go through here, and now we see all of the services and all of the DLLs that are associated, or all of the other information about that service that was collected when we ran that command. Okay, we can look at our task list file. We can see all of the current processes that are running, and we can save this off. And now we have a baseline for this system for normally running processes on the system. And if there's something that we need to investigate, we can compare snapshots. We can take another snapshot and compare these outputs. And instead of evaluating every single one of these executables, we would just evaluate anything that is different, anything that's either new or and even potentially missing. If something's missing, that could be something that's interesting as well. And this is going to help us prioritize our efforts. Instead of investigating everything, we only investigate the things that are important and the differences. And this is going to really reduce the amount of time it takes to understand what has occurred on the system. So just to recap, and I'm going to go ahead and scroll back up. Just to recap everything that we talked about. Okay, I went out and I located a new document that was provided by the National Security Agency that helps organizations understand how to create baselines for their systems using the commands that are provided by the operating systems. It doesn't require any third-party tools. Okay, you can create a snapshot of your system right now, then run the same commands later in the future. And when you compare those files, it's going to give you the differences between the two states, the differences between the two snapshots, and you can use that to understand events that are occurring within your environment on those systems, and also understand what attackers may have done within your environment, the modifications they made to your systems, so that you can prioritize some of your analysis, some of your responses. By doing this, you will reduce your response times and you'll also reduce your recovery times for your processes.
Thank you for tuning in to another concept overview with the SANS ICS and Cutaway security teams. Please let us know if there are other topics you would like us to cover in the comments below. If you enjoyed the content, please be sure to like and subscribe to the SANS ICS YouTube channel. This has been Don C. Weber of Cutaway Security. Go forth and do good things.